As you know, MODELZEN is one of our products that can automatically generate SystemVerilog models from your circuits. The first approach that MODELZEN uses is to generate a structural model of a given circuit, leveraging the circuit-level simulation capability of XModel. That is, MODELZEN first converts each SPICE element within the circuit into an equivalent XModel primitive, and builds a model by connecting these primitives with the same structural connections. While this structural modeling approach enables an automatic push-button flow for generating correct-by-construction, SPICE-accurate model from your circuits, a downside is that the resulting models are as complex as the original circuits, which may limit the simulation speed up achievable. For faster speeds and also for higher accuracies, it may be better to use functional models instead, at least for the parts of the circuit that we understand well. These functional models describe the input-to-output functionality of the circuits using a smaller set of XModel primitives, and often provide much faster speed with higher accuracies. So the question is, can we generate these functional models using the MODELZEN's push-button flow? The answer is yes, with the new user-defined model interface of MODELZEN. With this UDM interface, MODELZEN can generate higher abstraction models, including the functional models, with SPICE-calibrated parameters for any selected parts of the circuits. Let's take this circuit for example. It is a differential amplifier with a biasing network. Instead of relying on structural modeling with circuit-level primitives, I can select a part of the circuit that corresponds to a voltage reference generator and map it to a UDM named refgen. In addition, I can define the mapping between the nets of the circuits and ports of the model defined by the UDM. I can also select the differential amplifier and map it to another UDM named diffamp. Once this mapping is done, the steps for generating models are the same as before. Simply click Run MODELZEN icon, and that's it. You can see that the generated model contains functional model for the selected parts and structural model for the remaining parts. This is an example included in our phase lock loop tutorial. In a phase lock loop, or PLL, the voltage controlled oscillator, or VCO, is an essential part that generates a clock. A problem is that this is also a part that generates a lot of events during the simulation and can make the simulation quite slow. We can again use UDM to generate a functional model for this VCO that runs much faster. You can select the VCO circuit and map it to the VCO_V1 UDM. MODELZEN generates a functional model for this VCO, which is made of a piecewise linear function primitive, followed by a frequency-to-clock primitive. These numbers describe the voltage-to-frequency characteristics of the oscillator, which is extracted from the SPICE characterization run by MODELZEN. In this PLL example, we found that just modeling the VCO and the frequency divider as functional models using UDMs achieved almost 17x speed up compared to using all structural models. With this new UDM interface, MODELZEN is now a versatile platform for generating both structural and functional models. For a few critical blocks that detect the speed and accuracy of the simulation, use UDMs to generate the functional model. For the rest, just let MODELZEN generate the structural model. Then, your SystemVerilog simulation will be just as fast as using all hand-tuned functional models. Thank you.